Hi, I'm Adam Haney with More Technologies, and today we're going to be talking about using a web browser and how we can target a PLC system to exchange data with that PLC. Specifically, we're going to be using a Beckhoff runtime, so Beckhoff's XAR, their TwinCAT XAR, and some of the APIs that they provide for communication between a web browser and a PLC. And this is part one of a two-part video. In this first part, I just want to discuss mostly the fundamental concepts that go into creating a web application and how data is going to be transmitted between our PLC and our web browser. And in the next video, I want to show how the things we've learned in this video, or the way that we see how Beckhoff is allowing a web browser to target their PLC runtime, I want to show how in Beckhoff's IDE, in the TwinCAT XAE, when you use like the TF2000 TwinCAT HMI function package, how that's very similar to essentially what you're doing when you create your own HTML, CSS, and JavaScript web app using their APIs. So the objectives for this video is pretty much to explain how traditional HMIs work, and then we're going to go over the basics of HTML, CSS, and JavaScript, and then we're going to look at the major parts that go into serving a web application, which is a web server. We're going to look at Simple Object Access Protocol, SOAP, which is the messages that TwinCAT is going to use between their runtime and the browser. We're going to look at what a Web Services Description Language file is, and also what dynamic linked libraries are. And then the last part of it is we're going to look at how the code is being used to make all these packets and all these messages that are going to be transmitted back and forth between our web browser and our PLC system. Okay, so I want to give you a preview of what we're going to be doing in this video. At the end of it, what we're actually going to be creating. And so, as you can see on the screen, this is just a web document that I've created. It's a naked HTML, CSS, and JavaScript file that is targeting a runtime that I have on my local machine, a TwinCAT runtime. And so all we're really doing is just creating an application that, when I click the start button, it's sending a value to this motor object that I have that has an attribute of start. And as I do stop, standby, I'm manipulating the values in the PLC, just like if you had a visualization system that was sending a start request to your PLC, a stop request, to put the motor in standby. And then as I read the value of those variables that I'm writing to, I dynamically have JavaScript that is changing the properties, the CSS properties of elements on the web page. And so that's how we're changing the background of this motor to reflect the status of the motor in the PLC. Is when I click stop, it sends a stop command, and then I read back a value, and then based on that value, my JavaScript will grab the background element of this image, and it will change the background color attribute, CSS attribute, to change the color. And then also you can see, I can because I'm cyclically reading from my PLC, I can force this fault value. So I just forced the fault value in my PLC, and now you can see that the background is turned red, okay? And then if I click reset, okay, it resets that fault. So that's a preview of what we're doing at the end of this. What we should be able to walk through and see how to make an application like this. And this is obviously a very simple example, but the same ideas can be scaled out to make much more powerful visualizations. Okay, so now we're going to look at a traditional SCADA architecture. And that's largely a three-part process. For most people that come from industrial automation, you're familiar with like WinCC or the InTouch Window Maker Suite, which is now Aviva. So the three parts are your development environment, your runtime application, and then the communication protocol management system. So whatever software is being provided to kind of configure how you're going to target your PLC. So the first part, your development environment, this is Window Maker, this is WinCC, this is where you're creating these windows and creating visual objects on the screen that have some attributes based on what type you create. So if it's an input box, you can say, hey, on click, bring up a number pad, or I accept real values or integer values, or I accept strings, I'm a text box. And so that's where you're creating your application and defining the functionality that you want your HMI, your SCADA system to have. Then you're going to deploy that. So you're going to build it, you're going to compile it into some software some runtime application that you're going to start on your clients. So all these computers in the field that you want to visualize the process, they're going to use this new application, this executable that you run, that's then going to communicate back to your OPC server to then target your PLC and bring information back cyclically between those two. And so the third part would be like Orchestra, where you're defining, okay, this is the driver that you're going to use. These are my nodes in the field. These are the 3 different PLCs I have. This is their IP address, or if it's Modbus, this is the this is the addresses I've got and the different registers I've got for that information. And that's what allows your runtime application to say, hey, go talk to this access name. Your OPC server will resolve that access name. It says, oh, well, really, this is some IP address, and I'm using this protocol to talk to that PLC, and then it will go out and fetch that information and bring it back, or it will write that information depending on what kind of operation you've chosen in your visualization. And so now I want to look at some of the disadvantages of a traditional HMI system. So one is licensing costs. So many people are familiar with this idea of client licenses or runtime licenses. That's kind of been the business model for a very long time for major manufacturers. And that's really costly, because if you've got 20 computers that you want to visualize a process on, now you've got 20 runtime licenses, and if those are recurring costs, then every year you're dealing with that. And that flows into the next issue, which is vendor capture. So you've got all of this institutional knowledge, all of this work that you've invested to create a nice SCADA system for your process, and it's all locked up in this proprietary system. And so if you want to migrate from that, you've got to find some way to basically essentially fully recreate your system in some new format. And that's either finding an integrator to do it, or to have certain people on staff that are only dedicated to that upgrade. And then there's the cost of testing it before you deploy it, troubleshooting it. And then the next issue is specialized knowledge. So not only do you need people that are proficient in process control and this idea of interacting with an industrial automation system, but they need to have a special subset of knowledge just for this software package, right? This isn't translatable information. To some degree, there are basic concepts that you get by working with one software suite that you can translate to another one. This idea of inputs, this idea of data manipulation. But as far as like knowing where to click or how to parameterize things, that is very specific to the software you're using, and that doesn't translate well. And so that makes it difficult to find a labor force that can maintain, or at least there's going to be some time that you have to send someone through training to get up to speed on just where they need to click to do the things that they know how to do, but now they've got to find out how to use this software. And the next issue is heavy runtime applications. So you're actually deploying an executable, a software package to the field that your clients are running on, and that gets into issues with having the right, it's compiled to the right OS, this is Windows compatible, or it's Mac compatible, or it can run on Linux, because you're actually deploying an application. You're not just deploying like a web browser document. And that's all. They're also heavy, so that puts some lower limit on the hardware specifications that you can use for your clients in the field, because they've got to be able to run this visual application. They've got to be able to do it well. You don't want it to be laggy. You don't want it to take forever on startup. So that puts some constraints on the actual how light your hardware can be in the field. And then the last major issue is the small community. So because you're dealing with a small subset of all software in the world, industrial SCADA system software, you don't have a huge community to draw information from. And also for vetting out the software itself, that's left largely up to the users, the companies that are using that software, to find bugs and push them back up to the manufacturers. And also it's on the manufacturers themselves to try to find out and vet their software, continually. And also when you're trying to ask questions, they're pretty much, their forums or their 1-800 numbers are pretty much the only people you can look for help. So now I want to talk about a modern approach to create a visualization or a SCADA system with web browsers. And so the first step is always with the operator, the person that's going to be monitoring this process and controlling this process. And so they're going to open their web browser, and they're going to type in an IP address or a URL that has some domain name in it, and they're going to make an HTTP request of a web server. And that request is saying, hey, I want some resource that the server knows where it is. I want some resource to be delivered back to me, the operator, in my web browser so I can see it, so I can see this visualization. And we do this every day, right? When we open our web browser and we type in some URL, we're not typing in an IP address, we're typing in a domain name, and then that domain name gets resolved to an IP address. And so, our web browser sends a request to that server located somewhere and says, hey, I want this document. I want this document, or I want this resource. It could be a video, it could be a sound, it could be, most often for us it's a web page, but it says, hey, go to this server and give me this resource that I'm requesting. So the web server handles that request. It says, okay, I see what's going on here. You want some resource that I have. I know the path to that. Specifically with our application and how we're going to target a PLC, what happens is the operator contacts the web server then brings up that document and sends it back to the operator. But behind the scenes in that document is JavaScript. And so that JavaScript, which we'll go into a little bit later, that JavaScript is adding functionality to make the website interactive. So this is really the difference between a web app and a web document. A web document is some static file that gets served back to the client so they can see, some pretty visualizations, some text. It's like a newspaper article that doesn't change, right? That's served back to you. A web app is where the operator, the client, can make changes to that document that gets sent to the server. And also, the server can then make dynamic changes to the data and send it back to the client or the web browser where our operator is. And so that's really what's going on with our application using Beckhoff's JavaScript libraries and their APIs. Is once that web page is brought up, once that web app is brought up, in the background, JavaScript is using function calls to talk to our PLC and get information back from our PLC to update the screen at some interval. And so the third part of this is those JavaScript functions, they're targeting data that's outside the browser. And JavaScript runs in the browser. The engine that is running JavaScript is limited to the browser and some web APIs or some objects that are related to the browser. But there needs to be some helper software that's on the outside of the browser because we're trying to talk to our PLC, right? Our PLC doesn't live in the browser. Our PLC lives somewhere on a computer or a target hardware. And so we're going to need some helper software to help us go from the web browser to where this PLC runtime really is, and then bring the information back. And we'll get into that later, where we're using these dynamic links libraries that are provided by Beckhoff to actually kind of close the loop on operator makes a request, web server shows a document, JavaScript makes a function call, JavaScript function call acts on a DLL to get information from the computer itself and then bring it back to us. So now I want to talk about how an improved browser-based SCADA architecture addresses a lot of the drawbacks that the traditional system has, and how we can get a lot more value out of a browser-based system. And so the first one is licensing costs. So there's some SCADA manufacturers like Ignition that when you buy their system, you get unlimited client licenses. And that's huge, right? So you can deploy as many clients in the field as you want, and you're only being licensed on a server license. So it doesn't matter if you have 1, 10, 20 clients in the field that are using your visualization, it's all the same cost. And then you have some other systems like Beckhoff where they actually sell a server license. So if you want one server that's going to be serving all these documents to your clients, that's going to be one web server that's taking all the requests from multiple clients and is sending out those documents that they're requesting. You have one server license, and then you can have multiple packages that you buy for your client licenses. So you can have 3, 5, 10 different client licenses, and that is for your web browser. And they're not tied to any single piece of hardware. If you look at the documentation, Beckhoff's documentation says that if you've got 10 web browsers and 10 licenses, then you can have them all running concurrently. But if you shut down a web browser on one PC and you start it on another one, that's still only 10 web browser licenses, and so there's no extra cost you have to pay. You're still only using the 10 client licenses that you purchased. And this leads into the next major benefit of using web browsers to serve information or as your visualization system, is that this is not specialized knowledge. There's an entire world of front-end and back-end web developers that they're computer scientists, they're computer engineers, or they've come into the field however they've come into it, and that's what they do, is make web applications. And so while you are going to be using some IDE, like if you're using Beckhoff's TE2000, their TwinCAT engineering, and also their TwinCAT HMI package, yes, it's in a specific environment that you're writing your code, which it's Visual Studio, so that's a great segue for traditional front-end web developers to get into the industrial space. But at the end of the day, you're using the same standard protocols and the same standard languages that the web is based on: JavaScript, CSS, HTML. So your labor force that you can get people in to quickly make web apps that are scalable and have great functionality, you've got so many more people that you can hire for that job than when you were looking for a small subset of people that just knew this one specific industrial automation visualization system. So to me, that's huge, and it brings in people that have sometimes more of a traditional education in computer science or in computer engineering that can kind of think about how, okay, this is how we would properly scale out this system, or this is how we, add performance value to this system. And then the other thing is lightweight applications. So these are web apps. There's no runtime that's deployed. There's no proprietary, binary file that gets compiled and has to get sent out to the field and then that be ran as an executable to show your visualization. It's all running in a web browser. So if you want to use Chrome, or if you want to use Firefox, if you want to use Internet Explorer, like whatever you want to use, as long as it's using HTML, CSS, and JavaScript, your web browser can visualize it. And so that's a super lightweight application. So that means that the devices you can run these web apps on are almost unlimited, right? Like anything that's got a browser can probably support your web app. Now you can get into some more intense graphic manipulation that can cause issues, but largely you can deploy web apps on far more devices than you could a traditional HMI system. And then the last thing is there's a huge community. So the underlying code is based on these standardized languages. So there's a huge number of resources that you can go to on the internet, or books that you can get to be a better developer, to answer these questions that you might run into. And yes, there's going to be some specific questions for software developers for like Ignition or for Beckhoff, but there's usually forums for that, or there's some web documentation. But still, at the end of the day, you're using technology that has a much larger user base that can help you out and answer questions when you run into problems. So I want to step through the parts, the major parts of accessing our PLC, our Beckhoff PLC, TwinCAT runtime from the web browser using Beckhoff's TcAdsWebService.dll and their JavaScript library. And we're going to see that later when I show the code, but these are the big parts that go into allowing us to actually target our HMI, or target our TwinCAT runtime and get information back from it. So the first part is our web app. We're going to make a request of the web server, an HTTP request of our web server, and that's going to give us some web document that's made of HTML, CSS, and then JavaScript in the background. So these JavaScript functions are going to package a SOAP message, a simple object access protocol message, as a string, and we'll see that. And so we've got this message that has been configured that we are then going to hand over to our DLL. But the SOAP message needs to know, the SOAP message is a message to access some software that provides more functionality than just our website can provide. Because our website the JavaScript is constrained by the browser itself. That's one of the major boundaries of JavaScript, is that when it runs in the browser engine, we don't want it to be able to do whatever it wants to our system, because that's how viruses start, right? That's how manipulation of the client's hardware can become a problem. So JavaScript is constrained to a large degree to the browser and the browser object and some other things that we'll look at. So we need an intermediary to actually interact with the file system, to interact with our OS. And so that's what the SOAP message is going to do. And so you can think of the SOAP message as this messenger that runs back and forth between this TcAdsWebService.dll that's providing advanced functionality that the browser can't provide. But we need to know kind of the language that the DLL expects, so that when we make our message, it can be properly formatted and our DLL can respond to that. And that's what this WSDL is doing. So this web service description language is is what's providing an interface to say like, hey, the DLL is exposing these methods, it's exposing this functionality to whoever wants to use it, and this is what you'll call it. So these are the names of the methods, and these are the arguments and the data types that those arguments expect. So you can think of this like you're using, you're programming in Python or JavaScript or whatever you're programming in, and you want to use some new module. Well, you import that new module, and then you look at the documentation, and the documentation says, hey, to use this method of this module you've imported, I expect you to call this method with this name, and it takes these arguments, and they have to be of this data type. And that's what the WSDL is telling to anyone that wants to use the functionality packaged in the dynamic linked library. It's saying, hey, if you're going to call for this functionality, the information you're requesting, these are the methods I have available, these are their arguments, and these are their data types. So the SOAP messages are sent to the web service that's hosted on the web browser. So the SOAP message makes an HTTP request of the web server, and the web server reads the header. It reads that message that's being in that HTTP request, and it says, okay, well, they're asking for a resource that comes from the TcAdsWebService.dll. And so it says, okay, well, I'm going to take this SOAP message, I'm going to send it on to this dynamic links library. So the TcAds web service unpackages the SOAP message that it gets. So now the web server has routed this message to the dynamic links library. That software, that added functionality that's written into the DLL, it says, okay, I need to unpackage this SOAP message and see what the browser is, what functionality they're requesting. Like, what do they want me to do? They're making a request of me. Let me parse this message. Let me read through this message and see what I'm supposed to be doing with it. And once it does that, then the requested data is repackaged into a SOAP message, and it's sent back, back through that route, back to get to the web app, so that the JavaScript running in the browser can kind of deconstruct that message and update the web page with whatever you've programmed it to really do. And we'll see that this will all make more sense once we kind of get to the application part and we walk through how we're making these calls, how we're sending this data. Okay, so let's start with kind of unpackaging what a web server really is. And so a web server is a system that responds to HTTP requests from clients to deliver content or services to those clients. And so your common HTTP requests are get, post, head, put, connect. There's some other ones, but largely most people are familiar with get and post. So anytime you're requesting information from a web server that you're not updating any data that you want the server to do something with, that's generally a get request. So in the header of the HTTP request, it will say, hey, I'm a get request and I just want you to serve this document or this resource that I'm requesting, me, the client, the browser. Just give this to me and I'll do whatever I want with it. A post request is generally when you want to update some information on the website, or on the web server. So you're saying, hey, I'm going to send some data back to the web server and I want you to do something with it. And that could be, hey, take this information and write it to a SQL database. Take this information that I'm filling out in a form, and when I click submit, that post request goes back and it tells the web server what it wants it to do with it. The main parts of a web server are their physical server, so it's what we would consider like the hardware. It's this server running whatever OS it is, the server operating system, and then the software used to facilitate the communication over HTTP. And some of the most common web server software is Microsoft's IIS, Apache, and Nginx. And so those are the operating systems that are running, or that's the web server operating system that's running on a lot of platforms out there to deliver content to the web. Those are some of the three most popular. And then we've got proprietary web servers that you'll see in industrial automation. So like Siemens packages with their S7-1200s and their S7-1500s their own web server. And I'm not sure, I don't know, I'm not privy to how the implementation of that server is, but if you buy that hardware, if you buy an S7-1200 processor, on it will be a web server that you can target, and you can program it to do what you want, to serve documents, so that when you type in the IP address of that PLC, it will serve a web document to you. And Beckhoff has the same thing. So if you're using the TE2000, the TwinCAT HMI engineering suite, and you use the TF2000 function package, Beckhoff installs a TwinCAT web server on your system, and you'll see it in your browser tray. And that is what's running, that when you're making requests with Beckhoff's HMI, with their web HMI, that's what's actually serving you the documents, is their TcHMI serve. And so now we're going to break down the pieces that we've been talking about for, web server is serving HTML, CSS, and JavaScript. It's facilitating that transaction to our web browser. We're going to break down the pieces and how they fit into actually making a SCADA system in a web browser. So HTML is our hypertext markup language, and it's the standard language for creating the content of a web document. Now, HTML is actually a subset of what is called XML, or extensible markup language. And extensible markup language, XML, is a protocol that basically says, like, hey, I am the definition, or I'm the standard for how a document can be portrayed, or how a document can be conveyed in an independent way. So you don't need to know anything about me or about the system that I'm running on to display an XML document properly. And it uses a tag system. And so you've probably seen in HTML the tags like head, endhead, body, H1, all these different tags that are used that's defined in HTML that provide some functionality to the presentation or to the content of a web document. And so HTML is a subset of XML in the sense that HTML has specific tags that have specific functionality. So like script, like when you have a tag that says script, that the browser parser, when it parses HTML, it says like, okay, I know what this keyword means. This tag means this specific thing. And the major thing to understand about HTML is it's not concerned with how the web document or the web app looks, but it's concerned with what the web document contains. So it is the content. It's not the presentation of that content. It's just the content that is on that website. So in our example, we just have a header. We've got a website that has kind of your boilerplate doc type information, and then we get to the body, and all it has is a header, H1, that says hello world, and then there's a button class. There's a button that's with it, but we can see that it's really what HTML is concerned with is just the content and not the presentation. So CSS, or cascading style sheets, this is the language that's used for dictating how the elements of our document, how they look. So this is where we target HTML elements, so elements that are in our browser, and we say, hey, I want these properties, these attributes, I want them to look this certain way. And so CSS is what's concerned with how the web app looks, not what content is on the web app. That's HTML. HTML says this is the content you're going to display, and then CSS says, okay, I'm making up rules for how this content is going to look. And we can see in the example, I'm basically saying that, hey, for my tables, I want them to have this width of the screen, and my table header, and my data cell, my TD, they're all gonna have a border that's 1 pixel and it's solid black. So CSS is just the language that tells our web browser how the content should look based on the tags, the HTML tags that content has associated with it. And JavaScript. So JavaScript is the scripting language that can be used to target the browser and the web document to create dynamic behavior. So the way that JavaScript does this is web browsers expose the document object model, or the DOM, and other web APIs to JavaScript so that JavaScript can act on that data. So every browser has a JavaScript engine that the JavaScript that you associate with your web page is going to run inside. So for Google, it's like Google's V8. That's very popular. It's a very powerful engine, and it's actually the prototype for what Node.js is based on, but that's a different discussion. So the web browser we expose certain objects like the document object model and the window object and some other web APIs to JavaScript so that JavaScript can act on those things. And so what the document object model is when you load a web page, the document object model is created by the parser that goes through your HTML, and it says, hey, I see all these elements, all these HTML elements that are on this page, and I'm going to create a tree-like structure that we will call the document object model, and if you come from a background of working with trees, like mathematical trees, computer science trees, there are methods for traversing a tree, right? We can start at the root and we can work out traversing all the elements of a tree. And that's what the document object model is. It's a tree data structure that represents all of the elements and nodes that are on a web page based on the HTML that you've programmed in there. So one of the limitations of JavaScript is that it's constrained to the browser. We don't want JavaScript. When we go to a web page, we don't want some nefarious JavaScript that's been written on this website to be able to just run amok on our hardware system, right? We don't want it to be able to leave the browser and do a whole bunch of stuff to our computer, and that's how we get viruses, that's how we get our information stolen. So to a large degree, JavaScript is constrained to the JavaScript engine that it's running in our browser of choice. And that's what creates some of this middleware that we need to facilitate reading data or writing data outside of the browser. And that's where the DLLs will come in. That's where these APIs, these application programming interfaces that Beckhoff makes available to us to actually target our PLC, that's where they come in. So I want to talk a little bit about how JavaScript works behind the scenes. And this is really important for industrial automation because some of the nuances of JavaScript can cause problems if we don't create our applications the proper way. So JavaScript runs in the browser. It runs in the browser engine, and that is the environment that allows us to take a JavaScript file and then execute it and parse the information and go out and do things that we want to do with our JavaScript. And so the major components of JavaScript in the browser is you've got a heap and a call stack. So the heap is where all of our variables and our objects live in memory. So we say, hey, var, b start button. Well, we've created a variable and we need to put that someplace in memory so that we can initialize it, give it values, read its value back. So that's what the heap does. The heap is where all of our variables and our objects live in memory. And then our call stack is the data structure that we use for as we encounter functions. So as we run down our JavaScript file and we encounter functions that are supposed to do something, we add them to our call stack. And so when we encounter our first function, that gets passed to the stack. And if there's a nested function inside of function 1, that will get passed to the stack also. And then if there's a nested function inside of function 2, that will also get passed to the stack. And that tells us where we are in our execution cycle. So the call stack informs our system where we are in processing our JavaScript code. And as soon as our functions return, then they're popped off the stack. So when function 3 returns in our code, then we pop it off the stack and we now go to function 2 and continue processing from where we left off. And then when it's done, we pop it off the stack and then we go to function 1 and we do the same thing. Now, that's great for all of the code that we've written into our JavaScript. So the things we want our JavaScript to do. But largely what we also want to do is we want to take operator input. We want to do things when the operator clicks a button on the screen, when the operator enters some value, some string value, and clicks enter or send or whatever. We want dynamic behavior with our visualization system, right? Well, JavaScript is single-threaded, which means that you have one thread to execute instruction sets on your CPU. And what happens with that is if we don't properly program a web application, if we don't do our JavaScript the right way, we get what's called blocking behavior, which means JavaScript encounters some function that says, hey, go off and load this video file. Well, JavaScript, if we have blocking behavior, if we have a synchronous call, what we call a synchronous call to that web resource, JavaScript will stop there. It will not keep parsing our document until that resource has been fully loaded on the screen, till we've come back from that call and fully loaded that resource that we want. And that creates blocking behavior where during that time, our event listeners can't listen for a button push. They can't listen for anything the operator wants to do. And that's really bad in industrial automation, right? If you need to stop a motor because something's going wrong, you want to be sure that when you send the request to stop that motor, it is being handled and it's not being blocked by something else that's taking priority. So the way that JavaScript handles this is with AJAX, or asynchronous JavaScript and XML. And that is what utilizes a callback queue and an event loop. So what the callback queue does is it's a queue, so it has first in, first out behavior. And what it's doing is it's listening for these events that we have put event listeners on. So if we've got a button on the screen that we've defined with HTML, that button exists on the screen, and if we give it an ID, it has some ID. Now in our JavaScript, if we get that element, that HTML element, and we say, hey, add an event listener to that button, what JavaScript does, it says, okay, I'm listening for any time that this button is clicked. And if this button gets clicked, I'm going to trigger an event that's going to call some function to do something with it. And that gets put into our callback queue. So when our call stack is empty, after we have processed all the functions that need to be processed and we're just waiting for events, anything in the callback queue starts getting pushed into our call stack, and that starts getting processed. And our event loop is, running through this loop of checking the call stack, seeing if it's empty. If it is empty, go to our callback queue and see if we need to bring anything in, any event in, to process that event. And that's what allows us to have asynchronous behavior, because callbacks in JavaScript allow us to say, hey, browser, go do something, and while you're waiting for that thing to return, go do everything else that is waiting in the code. And then once that function returns, like a callback, it says, hey, I'm done. I've done what you want me to do, and now I'm ready to go back so you can process that event that's returned. And so that's asynchronous JavaScript, and that's what allows us to create non-blocking behavior in our applications. And it's important that we do this because, if we program everything synchronously, we will have blocking behavior that does not take, updated inputs from the operator until everything else has been cleared out from the browser. Everything else has been cleared through the JavaScript. So one of the main aspects of talking to a PLC with the TcAdsWebServe API is this simple object access protocol SOAP message. And so the reason why SOAP exists, the reason why SOAP was developed, is because a desirable attribute for communication between different applications is interoperability, right? We want to be able to exchange data between applications that are written in different languages. We want to do it in a format that is distinguishable from both sides, that can be understood by both sides. So the solution to this was to create SOAP, which is based on XML that we talked about earlier, extensible markup language. So this allows us to easily interchange data between different applications because we're not concerned about the implementation of that application that we're talking to. We just need to know that there is an interface that supports SOAP to send these commands and requests back and forth between. So that's what we're doing. We're using a SOAP message to make a request of the TcAdsWebService.dll that's hosted on our web server that will actually talk to our file system, talk to the runtime environment of TwinCAT. That's what we're doing with SOAP. And so the main components of a SOAP message are its envelope, its body, and its name of the service. And so this example on the screen has actually been taken from the JavaScript library that we'll see. So the TcAdsWebService.js file is a library with all of these classes and methods that are written to facilitate the communication between our web server and our TwinCAT runtime. And so you can see that this variable, this message, it's just a string that has been put into a certain format that SOAP accepts, and we'll see how that format has been defined in the next slide. And you can see that we have variables for the right net ID. So if this is a local system, it will be localhost. If it's a remote, if the web server is targeting a remote TwinCAT runtime, then we need to have the proper net ID so it knows where to go to access to target that TwinCAT runtime and the port that we're using. So if it's 851 for TwinCAT 3 PLC, the index group of where our data is being stored. If I want a variable, I have to tell the TwinCAT system what index group this in memory this data lives at, and then I need to tell it the offset, because it's going to say, okay, I've gone to the start of this memory area where all of, let's say, the main PLC variables are kept. But now you want a specific data, you want a specific variable from this area of memory, so then we have to give it the offset that we want to start reading at, because that's where our variable is actually going to start. And so that's pretty much what this message is doing. It's making a package, this SOAP message, that we're going to send to the DLL so it can go to the right place in the TwinCAT runtime and get that information for us. And so the SOAP message is constructed, the message that we just saw, it's constructed based on a web services description language file that accompanies the dynamic links library, the TcAdsWebService library. And all the WSDL is doing is it's saying, hey, inside the DLL, there are these methods that you can use to read and write data, or read data, or write data. And this is the name of that method that you can use, that any application can use. If you send me a message with this proper name and with these arguments with the right data type, then I can take that to the DLL and it will execute some functionality and return it to you. So that's what the WSDL is doing, is just acting as an interface to advertise to anyone that wants to use the DLL, to any application that wants to use the functionality that DLL provides. It says, this is what you need to call, and if you call this, this is the arguments you need to supply with it. And so we keep talking about DLLs and what are DLLs? You know, what is a dynamic links library? Okay, so a dynamic links library is a library that contains code which can be used by more than one program at the same time. So think about a DLL as, you know, just a library of functionality that's written in some language that provides methods and classes that you can use to result in some behavior. And so what DLLs provide us to do is, instead of creating an executable that we have to build and deploy, and people, you know, you double click this exe and it does something, what a DLL does is it allows us to create a lot of functionality that can be used by different applications. So, you know, 10 different applications can target this DLL and use some of the functionality that it provides. And we don't have to run executable. And if we want to update that DLL, we don't have to redeploy a new executable. So specifically for our purposes, the TcAdsWebService.dll, it receives a SOAP message with some requested operation and then executes that operation on the TwinCAT XAR. And this is using Beckhoff's automation device specification ADS protocol. And so the TcAdsWebService.dll is what's actually interacting with the PLC runtime on the target system. And that's the important part about closing this loop, is that JavaScript in the browser is limited to the browser. It can't go out and talk to file systems. So we need a middleman to go out and accomplish that task for us. And that's what Beckhoff has done by creating this DLL that they provide. This is the API that is being used to go out and get that information. Okay, now what I want to do is to go through the code and kind of inspect the code and both the web page to tie all these things together that we've just talked about, to see how we're really getting data from the PLC and also writing data to the PLC. So we are going to start by looking at our HTML file. And it's a pretty simple web page. You know, there's some boilerplate at the top, which is your doc type information, some head information, and then just something to kind of point out is that our scripts, we're highlighting where our scripts are stored. And so this is the TcAdsWebService.js. That's the library that has a lot of the, well, essentially all of the functionality that Beckhoff provides for us to target our TcAdsWebService.dll and to send messages back and forth. So that's all kind of pre-configured in this library for us. And so when in our main script document, when we reference prototypes or methods that are contained in that library, that's how we're bringing it in. It's because we've said explicitly, hey, these variables and types that aren't defined in our script, you can find them in this library. And then so the next stuff is just, you know, it's a simple body. We've got a logo on there, and then you can see that we've just got some information about classes, like I've given titles to some things for my CSS, and we've got an image down here. So we've got image source, and then we've just got 4 buttons. And so I've created 4 buttons that have an ID. Now, an HTML ID is going to be unique So classes can be multiple HTML elements can share a class name, but IDs need to be unique. And if you've got IDs that have the same name, that's going to cause problems when you try to target them with JavaScript or CSS, because this is kind of these IDs and class names that we're giving our elements. That lets us select our HTML elements easier with JavaScript, because an important distinction to make is that you can explicitly create your elements in HTML. So like we've done here, I've got a button class, I've got a button that I've explicitly called out with the button tag in my HTML. So, you know, the browser knows that there's gonna be a button there. But another way to do this that actually we'll see in the second video, which is a lot of how modern, really truly modern websites are doing it, to kind of encapsulate and abstract away information, is that JavaScript can insert HTML elements into your document for you. So you can essentially have a completely blank HTML document that your accompanying JavaScript file is injecting HTML into that HTML document or that web browser when you're actually in the web browser. That web page when you're in the web browser. So that's just what we've done here. And just to kind of like to maybe make this make more sense, if we go to our web page and we hit F12 so we can inspect what's going on. If we go to our elements section, so this is all the HTML elements that our web browser has parsed. We can see that as we hover over these things, you know, it highlights these different elements on the screen. And if we start expanding these things out, you know, we see that essentially exactly what is in our HTML document, our file, is what's represented here in the Elements tab in Developer Tools. And that's just to kind of like drive home this idea that HTML is nothing more than the content of your web page that is driven by a tag system. So all these tags are giving explicit functionality that the web browser says, okay, I know what this is. I know this is a header. I know this is a button. And that's all it really is. Okay. So if we go to our scripts, so if this right here, this script.js, this is kind of like our specialized script for the web page. It's what's driving the interactions on the web page. And then again, this TcAdsWebService is just a library that we're borrowing from. And then we have a style sheet. I should have mentioned we have a style sheet. It's pretty simple. But this style sheet is just the CSS that I've kind of defined to give some default, graphic, visual appearances to our document. So like this border here, there's like a 1px border around this wrapper, and then it's how I'm saying the font size for this header, stuff like that. It's how I've done the background gradient for this, but it's nothing too special. So the real interesting part of it is when we get into script. So as we get into our script, this is where we can kind of start seeing really the valuable stuff that's going on, or the interesting stuff that's going on behind the scenes to let us talk to our PLC. So it starts out pretty simple. We've got our net ID, a port, and a service URL that we define as variables. Now in JavaScript, var is the keyword for global variable. So these are global variables. That's not too important right now, but as you get deeper into JavaScript, you've got different ways of creating variables. And so we say, hey, this document is going to be hosted at this URL, or this path, which is where our TcAdsWebService.dll is. And that's the web service that's hosted by the web server. Right now I'm using IIS, the Microsoft's IIS as my web server. And so when we start making calls to our web server for the DLL, this is the path that we're going to use, this service URL. And then the next part is the really important part, and that's where we're creating a client. So we're creating a client of type TcAdsWebService.client, and we're passing it these arguments of the service URL and then our port, or these two other arguments, which we can look at when we go to the library. They're null right now. And then we've just got some other information about, read loops, because we're going to be cyclically reading, delays, and then our handle names that we're going to be pulling we're going to be reading the data from our PLC by handle name. So I've explicitly defined in my TwinCAT project these variables in main, and if we go and look at that, we can see this here. So in main, I have bstart, bstop, standby, reset, fault, motor status, and these are the ones that I've called out. And to make this a little bit clearer, we can go to our instance and we can look at our data area. And we can see in our data area that, this is the data area is kind of like, hey, in memory, this is what this stuff really looks like. This is what your variables really look like. And so these offset values here is what we're going to see later as we target our index group to get to the right memory area in TwinCAT that we want to pull data from. These offsets is what we have to start giving our JavaScript functions. We have to start informing them about, okay, well, what offset do we actually want to read? Like, we're going to start at this memory area, but how far down do we need to go to get this exact variable that you want? Okay, and so if we go back to the JavaScript, it's basically, and all of this will be on a GitHub repository that can be pulled off. We'll have a link to that in the description. So you can kind of, in your own time, because there's, if we go through this, there's like 560 lines of code just in this one file. But what you'll find is that most of this code is all boilerplate. It's all data, it's all code that is setting up the communication back and forth between TwinCAT and the web browser. And so really the way to make this scalable, even though there's I think there's 8 lines of code that's actually changing the background color. Like, I've got some code for event listeners, and I've got some code for changing the background color of our motor image to inform us of what the state of the motor is. That makes up 8 or 10 lines of code. Everything else is setting up the communication and cyclically reading and writing data and then error handling. But to make this scalable, what we're really doing is this array of handles var names. Because we're using the handle names of the symbol, so like the full name of the symbol to read that data off of the PLC, the way to make this scalable is you just increase this array. And if someone, there's plenty of intelligent people that could find out ways to kind of template this and make this more scalable. But if you just populated this array with more handle names, then the boilerplate code stays pretty much the same. It's just saying, okay, well, now you've given me more handle names to find. I'll go out there, I'll find them, I'll bring back that data for you, or I'll write that data to you, or to the PLC. Yeah, so as we go through here, this is where we're initializing some UI elements. We're getting these, this button start, button stop, standby, reset, and motor background. This is some of the code where by the unique ID of that HTML element, we're using the document.getElementById method to grab that object. And so this is where we talk about the DOM and how the document object model, is this tree-like structure. So this document.getElementById, it's saying, okay, go through the DOM and find where there's an ID that matches this exact ID, so button start. And when you find that, return that object to me, and that's what we're keeping in this variable button start. And so that's what's going to let me down here create an event listener for that button. So here you see I've created event listeners, and later we'll define what those event listeners do. But that's all we're doing is we're saying, hey, JavaScript, go interact with the document object model, find this object, assign it to a variable, so that later when we want to act on that object, you already have it in memory, you already have it as a variable. Then as we go down, we can see a lot of this is from a template that came from Beckhoff. So I can put a link in the description for where some of this boilerplate code came from with Beckhoff. And we can see that we see our first, so our client.readWrite, this is the first instance where we're going to start using some of those library commands to do something with the PLC. And what's interesting is that if we compare this with the WDSL and with the SOAP messages, we'll see that all these arguments match the WDSL because we're interacting with the DLL and we need to give it the same kind of arguments that it expects. And you'll notice down here that this last parameter, this last argument is true for Ajax. And that's important because we want this asynchronous calls. We don't want synchronous calls as we're talking back and forth, creating these objects, making calls to our PLC. We don't want these things to be synchronous. We want them to be asynchronous so that we're not creating blocking behavior in our web app. And then as we go down, it's just the same thing over again. So on button start, what are we going to do? Well, when button start is clicked, we want to write some value to the PLC. And we're using some of these handles. This HStart is the handle for the start button. We're going to have a callback function, which means, hey, when this function returns, go and execute this callback function, which is really the functionality that I want programmed into this button click. So, you know, we get a button click, we do something, and then we go on and do whatever else we want. But once that event returns, once that function is returned, then I want to go do some other functionality. And that's kind of what you see down here is like, this is the callback function, and all it's really doing is saying like, hey, if it's been successful, if we hadn't had an error, then you're fine. But if we have had an error, then I want you to console log, you know, what that error was. And this is where, you know, in a real visualization or real SCADA system, this is where you'd want to program all of your error handling, all of your corner cases where something's gone wrong. You know, that's largely abstracted in traditional HMIs and traditional SCADA systems where you're working inside of a larger model made by an OEM. All this stuff is kind of handled in the background for you. But when you're doing it this way, when you're directly creating these communication pathways, you have to program yourself all of the corner cases and the exceptions that you need handled. Because if not, there's nothing else that's going to tell the program what to do. And that's why, while we're kind of highlighting how you can make a web app yourself just by coding it from the ground up, that's why there really is a lot of value in using these software suites like TE2000, TF2000 by Beckhoff, because so much of that is abstracted away and handled in the background for you, where, you know, if there's a failure read or write to the PLC, if a read or write fails to the PLC, that's handled for you in the background. And that's really important when we're talking about industrial applications where we need to have 99.99% uptime, and we need to handle all of our communication properly. And so again, this is just kind of repeated for every button. We do the same thing. But the really interesting thing that I want to call out is as we get up here to our client, to actually determine what is writing to the web server, what's making calls to the web server to affect this communication. If we go into our TcAdsWebService library, and as we scroll down, we start seeing these different objects. So this is the TcAdsWebService object. So here is, at the very beginning, we create this object, and then we have all of these methods that are associated with it. So this response, this error, this request. So here we get to this client. And we can see that our arguments that we saw on the in the last page was our service URL. That is where our DLL is hosted at. So that's the address that our web server is hosting that web service, the TcAdsWebService, the .dll. And then this is, we had seen on the previous page or in the previous code that these arguments were null. That's because I don't have a password, I don't have a username for this service right now. So that's why that was null was passed in there. But then again, bringing this full circle, we see that the message that we're packaging for this read-write method or this read state method is a SOAP message. And it corresponds to the WSDL, the WSDL, the Web Service Description Language. It conforms to that so that the DLL, when we call this .read-write, when our client is saying, hey, I'm going to do this read-write function, the message that's being packaged is in the appropriate format that the DLL will accept. And we see that as we go down, this is the same thing over and over again. For our read state method, for our write control method, for our write method, all of this is just kind of, it's the same approach to creating a SOAP message, sending that SOAP message to the web server sends that to DLL, the DLL handles that, and it affects the functionality that we want. And now, this is really where the magic's happening, right here in this handle sync response or in this handle async response. And so I'm going to go down to the async section because we're making asynchronous requests, we're making AJAX requests. So if we scroll down here, this is where we start getting into how we're actually calling the web server. And so if you see this XHR is the variable for this XML HTTP request object. And that is a standard JavaScript object for making a call to a web server. And if we scroll down, we'll see where this actually gets parameterized. So if we come down and we get to our right here. So in our send message, we're going to come down and we see this, let me find it real quick. We have our XHR new XML HTTP request. So here we're creating a new XML HTTP request object. And if you look at the documentation, you can Google XML HTTP request and it will tell you exactly what's going on, the different methods, the different arguments. And this is what's actually, when it gets called, is going to make a call with a get, a post, a connect, a put. It's going to be making it's going to be affecting the HTTP request to our web server to then talk to our DLL. And so if we come down, we'll see that we're saying open. So xhr.open is where you give the arguments that you want for the type of XML HTTP requests that you're making. And so like we talked about earlier in the video, there's different types of HTTP requests. A GET is largely when you're pulling information from a web server, and a POST is when you want to send some data back to the web server so that it can, do something with that, to either store it or manipulate it or, whatever. And here we see that, if we have a service user and password, which we do not, that's null, so we're going to come here. So we're using our XHR open post, so that's the type of request we're making. And we're doing that to our service URL. That's where the DLL, the web service, is hosted at. And it's async. So the third parameter in the XML HTTP request object is asynchronous. It's a Boolean for whether this request is asynchronous or it's synchronous. And because we've specified that we want asynchronous requests, we've given this value true. So that means that this open function, or this XML HTTP request, is going to go out, it's going to make the request, and then it's going to go on, the code's going to go on and do whatever else it wants until it receives confirmation that that XML HTTP request has been successful, or it's errored, or we get some response object from the web server. So that's the cycle of calling a web server. You have a request, so the request is client makes a request to the server. Then the server responds to the client with a response object. So there's a request object and a response object, and that's what creates that closes the loop. So that's the full circle in a client talking to a web server and then getting a response back. And so then we see that down here we set our request header. So what's the type of data that we're sending to our web server? And this informs, the request header informs the web server how it should be handling this data, what it needs to parse it with, what it should expect earlier in the code. It's this SOAP message based on the type of method you're calling, whether it's a read, a read write. That's what's getting packaged inside of this function that's being sent to the server. And then we're going to wait for the response. So you can see up here, if async, because in the documentation it calls out that we need to open and send our XML HTTP request before we can handle the response object. And that's just kind of a convention that's used with the XML HTTP request object. So on state ready change, we're going to handle this callback, this XHR, this callback, and then we're going to go on and do what we're supposed to be doing with that code. And so, this library is basically just telling you all the functionality that you need in your script, that we're calling in our script. It will come from this library. And as we go down, we see, again, we have all of our buttons, their callbacks, all that functionality that we need is kind of in here as boilerplate. And then this is where we're reading handles from the TcAdsWebService, the data reader object. So it's saying, hey, you've defined these handles. I've gone out to the index you want at the proper offset, and I've read this symbol handle back to you, and this is the data that I've gotten. And here we need to specify, the size that we're reading. All these handles, I believe, are, deints, so they're double integers, and that's why this is all kind of in here as a double integer. And then we get down to our read loop, which is just saying, okay, we're going to read data from the PLC. We're going to do it at this delay, and that's what's cyclically making this read-write cycle to our PLC. And then really, like I said, that there's very few lines that are actually changing what's going on in the background, and that's right here how we update the motor background color. It's this 4 lines of code here where I check this integer value that I have in the PLC that tells me my motor state, and if that motor status is 0 that I've read from the PLC, then I'm going to this motor background object, which we grabbed earlier in the code with that document.getElementById. So that's what that object is. Previously we referenced that HTML object earlier, and all I'm saying is, hey, act on the CSS style property. So JavaScript has a built-in function for acting on the CSS properties of an HTML element. And so I'm saying, hey, go to this object, that's an HTML element. You're going to be acting on the style, and I want you to change the background color to dark gray. And in CSS, there is a list of, I think it's like 127. There's some number of colors that actually have a proper noun, a name to them, and that references an RGB color scheme. And dark gray is one of them, chartreuse, Dodger blue, red. It's just an easier way of using colors instead of having to give their hex value or their RGB value. So all I'm saying is, like, hey, when the motor status is this, find this element and change the color of it. And so this is what is, these 8 lines of code, whatever it is what's changing the background color based on the PLC variable. And so then, just to bring this kind of full circle, so we can see what's going on with our XHR request. If we go to developer tools in your browser, and you've got to have your web server running, you've got to have your TwinCAT PLC running, but we go to network, and if we come down here, we'll see that, like, all of these requests, my requests are growing here, right? 35, 36, my requests are growing because my JavaScript script is calling the web server, which is using that web service, this TcAdsWebService. It is making these calls, these XHR calls that we saw. So this is the XML HTTP request object, and it's getting status codes 200, which status code 200 that's a good code, right? Like, sometimes if you go to a web page that's a document that's part of a web page that isn't found, you'll get a 404 request. Or if you get an internal error on your server, on the back end of the web server, it encounters some error, you'll get a 500 status code. Or you'll get a 404 status code for a missing page. And so 200 is just saying, like, hey, my request was successful, everything went well. And so we can see that this object that we talked about earlier, this XML HTTP request, is what's cyclically writing, making calls to the web server, which is then using the DLL, which is then targeting the PLC and coming back to us. And so that's kind of the full circle on how we are getting this dynamic behavior from our PLC, from our web browser to our PLC. And so in the next video, we will talk more about, we'll make a comparison between how we have created this web app and interface with our PLC. We'll compare that to how TE2000, the TwinCAT HMI, and the TF2000, the Web HMI package, is essentially doing the same thing. It's doing it in a much more elegant fashion, and it's doing it in a way that is better because it's handling all these corner cases and exceptions in the background for us. And so that's pretty much the video for now, and thank you very much for your time.